There is a silence in the night sky that has bothered me for as long as I can remember. You look up and see thousands of stars, and your impression, that visceral instinct that helps you dodge traffic or catch a ball, tells you that somewhere out there, someone must be watching you too. It seems impossible that we are alone, but here's the problem with feelings. They were shaped to keep you alive on the African savanna, not to decipher the structure of the cosmos. But when you take that human intuition and apply it to the scale of the universe, it doesn't just fail, it breaks down, it gets crushed. Because the moment you really analyze the math, the instant you look at the raw physics of how time, energy, and distance actually work, you're forced to face a terrifying question. Why on earth do we believe that our instinct has any authority over the laws of nature? You see, on Earth, if you want to go somewhere, you just go. If you want to move faster, you put in more effort. But out there, the rules change completely. The universe has set 5 specific and relentless verdicts. 5 absolute walls that prevent civilizations from meeting each other. And be honest with yourself. They're not just obstacles, they're dead ends. When we get to the end of all this, you might feel smaller than you've ever felt before. But you'll also understand exactly why no one came to save us, and why no one ever will. Shall we abandon science fiction? Shall we leave behind Hollywood fantasies? Shall we face the universe as it truly is? The first verdict, and the one that blows our minds before we even leave the ground, is the distance. We say the word space naturally, but we have no idea what it really means. We are biologically unequipped, incapable of understanding the numbers we are about to discuss. Your brain was programmed to understand distances you can walk or travel by car. Maybe if you travel a lot, you can imagine the flight distance between London and Sydney. That's your limit. So let's try to expand that limit. Let's move up the scale. Start with Earth. It's a rock with a diameter of 12,742 kilometers. For you, that's the whole world. For the universe, it's just dust. You can circle the planet in less than 2 days. It's something manageable. Now take a step back. The sun is 150 million kilometers away. Light, the fastest messenger there is, takes more than 8 minutes to cross that distance. If the sun disappeared right now, you would still be enjoying a sunny afternoon for 8 more minutes before the lights went out. That's an interval you can still somehow measure in terms of time. But now take the next step. The closest star, not a distant galaxy, just the neighbor next door, Proxima Centauri, is 4.24 light years away. Now your intuition hears 4.24 and thinks it's a small number. I can do 4 of something. But let's translate that to the human scale. The fastest object humanity has ever built is the Parker Solar Probe. It tears through space at about 692,000 kilometers per hour. It's an unbelievable speed. If you boarded this probe heading toward Proxima Centauri, how long would the trip take? Month? Year? No, it would take 6,600 years. That's the closest star. If you had left Earth at the exact moment the Great Pyramids were being completed, traveling at the fastest speed humanity has ever achieved, you would be arriving now. And that's just the next door neighbor. Let's zoom out again. The Milky Way, our galactic city, is 100,000 light years across. If you wanted to cross it at the speed of the Parker probe, the journey would take hundreds of millions of years. That's longer than the entire evolutionary history of mammals. You would evolve into a completely different species before reaching the halfway point. And before we delve too deeply into existential emptiness, I want to ask you a small favor. We're going to tackle even heavier concepts, like why time travel is impossible and why your biology is incompatible with space. If you want to keep exploring the darkest corners of physics with me, Take a second to hit the like button. That signals to the algorithm that you value truth over comforting lies, and it helps me keep making these deep dives. All right, we've already established that space is immense, but maybe you're thinking, so what? We just need to go faster. And that brings us to the second verdict. The cruelest of all, the speed of light. Most people see the speed of light, about 300,000 kilometers per second, as a technical challenge, something similar to the sound barrier. Before, we thought it was impossible to fly faster than sound. Then we built better engines and we did it. So, we just need to develop a more powerful engine to break the speed of light barrier, right? Wrong. The speed of light isn't an engineering limit. It's a structural limit of reality. It's the speed of causality. It's the maximum speed at which an event here can influence an event there. Here's the catch. In our daily life, if you push a car, it accelerates. If you push with twice the force, it accelerates twice as much. That's linear thinking. But as you approach the speed of light, physics stops being linear and becomes asymptotic. As you accelerate an object, it gains kinetic energy. But when you approach that cosmic speed limit, something strange happens. The energy you put into the spaceship stops increasing its speed and instead makes it effectively heavier in terms of relativistic mass. The more you push, the more the universe pushes back against you. To get a spaceship with mass to reach 100% of the speed of light, you don't just need a lot of energy, you need infinite energy. I'm not talking about all the energy from the sun. I mean literally infinite. There isn't enough energy in the entire observable universe to accelerate a single grain of sand to the speed of light. It's a vertical wall. You can reach 90%, maybe 99%, maybe 99.9999% if you burn energy equivalent to an entire galaxy's worth of fuel, but you'll never cross that limit. So, when people ask why aliens don't come here at higher speeds, the answer is simple: because they can't. It doesn't matter if they're a Type 3 civilization that feeds on black holes for breakfast. They still live in the same universe as we do. They still obey Einstein. And that brings us to the practical nightmare of interstellar travel. Let's say you accept the speed limit. You decide, okay, let's go at 1/10 the speed of light. That's slow for the universe, but incredibly fast for us. And here we come to the third verdict: the energy and the tyranny of the rocket equation. This is what really kills the dream. It's not a philosophical question. It's a matter of fuel tanks. In 1903, Konstantin Tsiolkovsky wrote the rocket equation. It sounds kind of boring, but it's the most brutal equation in history. It says the following: to move a spaceship, you need fuel. But fuel has mass. So, to move the fuel that propels the spaceship, you need more fuel. But that extra fuel also has mass. So, you need even more fuel to move the extra fuel that you need to move the original fuel. It's an exponential curse. Let's use a concrete example. Imagine you want to send a spacecraft to the nearest star, and you want to do this within a human lifetime, let's say 40 years. You need to accelerate to a considerable fraction of the speed of light. And then, and this is the part everyone forgets, you need to stop. You need to slow down when you get there. That means you have to carry all the fuel needed for the braking maneuver throughout the entire galactic journey, accelerating the whole time. If you do the math using our best current chemical rockets, the amount of fuel needed to accelerate a single human being to reach Proxima Centauri within a reasonable time frame would require more mass and fuel than the entire observable universe. All right, let's move on. Let's use nuclear fusion. We don't have that technology yet, but let's imagine we do. Even with fusion, to send a small ship to a nearby star, would it have to be made almost entirely of fuel? We're talking about a flying tank the size of the Empire State Building to deliver a payload the size of a piece of toast. What about antimatter? That's the holy grail, right? Antimatter is the most powerful energy source there is. A single gram could devastate an entire city. But here's the problem. We produce antimatter in particle accelerators, atom by atom. It costs billions of dollars to produce just a few nanograms. To produce enough to fill the fuel tank of a starship, you would need to dedicate all of humanity's energy production for millions of years just to fill the tank once. And remember, the universe operates based on a cost-benefit analysis. Even if a civilization is advanced enough to capture the energy of a star, a Dyson sphere civilization, it is also advanced enough to do the math. They would analyze the energy cost of sending a flesh and blood being or a robot to a small blue planet 10,000 light years away and conclude that it's an absolute waste of resources. Why consume the energy of an entire star to visit a planet that might not even be interesting when that same energy could build a virtual paradise in your own backyard? Advanced civilizations are not just powerful, they are efficient. And interstellar travel is the very definition of inefficiency. But let's say they're stubborn. Let's say they have unlimited resources and completely ignore the laws of efficiency. They launch the ship. Now they face the fourth verdict: biology. We love to imagine humans in spacesuits hopping around in style, but the human body is a dramatic creature. It was shaped for one specific environment, Earth. 1G gravity, atmospheric pressure, magnetic protection. Space is a radioactive hell. The moment you leave Earth's magnetic field, you're being hit by cosmic rays. They're not just light. They're high-speed subatomic projectiles, protons and heavy ions moving close to the speed of light. They don't just touch your skin. They go through the hull, pierce your body, and shatter your DNA like a load of buckshot fired into a library. On a trip to Mars, the risk of cancer skyrockets. On a trip to another star, you'd be dead before passing Pluto. You'd need shielding meters thick, lead, water, concrete. But remember the rocket equation. Shielding is heavy. Weight requires more fuel. More fuel means more mass. It's the cycle of destruction again. And it's not just the radiation, it's gravity. In microgravity, your bones dissolve. Your heart shrinks from lack of effort. Your eyes become deformed. After 6 months on the International Space Station, astronauts return to the ground in terrible condition. Imagine a 600-year journey. Just put them in cryosleep, you say. Well, freezing a living cell causes the water inside it to crystallize, forming tiny spears that destroy the cell membrane. We don't know how to freeze a person without turning them into mush. Generation ships, you suggest, that they live and die on board, and their great-grandchildren's great-grandchildren arrive at the destination. Have you ever lived with human beings? Put 500 people in a metal can for 500 years. Social structures will collapse. Language will change. The genetic defects caused by inbreeding will multiply. When they get there, they won't even remember why they left. And they certainly won't be in any condition to negotiate any treaty. Biology is Earth's software. It doesn't run on space's hardware. But maybe the aliens aren't biological. Maybe they're artificial intelligence robots. Silicon doesn't develop cancer, right? True, but silicon is also sensitive to radiation. High-energy particles flip bits in computers, corrupting the data. Over thousands of years in deep space, without any technical support to fix the hardware, entropy takes over. The circuits degrade. The metal undergoes fatigue. Micrometeoroids the size of dust grains collide with the ship with the force of grenades because of the relative speed. Even a machine has an expiration date, and the galaxy is vaster than any other. And now we come to the fifth and final verdict. What really explains the silence? Information and time. Let's suppose that a civilization overcomes distance, energy, and biology. They're out there. Why not make contact? Because the universe offers terrible phone service. We've been broadcasting radio signals for about 100 years. That means our presence has formed a bubble around Earth with a radius of 100 light years. In the context of the Milky Way, which is 100,000 light years across, our bubble is a microscopic dot. We're shouting inside a hurricane. For someone to hear us, that entity would need to be pointing exactly at us, at the precise moment, on the exact frequency. Think about the size of the cosmic haystack. There are billions of stars and billions of frequencies. If an alien points their radio telescope at Earth, but does so in the year 1500 AD, they'll hear silence. The radio hadn't been invented yet. If they listen today, but are 200 light years away, they'll hear silence because our signals haven't reached there yet. This brings us to the problem of asynchronous civilizations. Civilizations arise and disappear. Humanity has been technological for only about 200 years. We might last another 1,000, maybe 10,000 years if we're very lucky. But the universe has existed for 13.8 billion years. The probability of two civilizations coexisting at the same time, in the same neighborhood, at the same technological level, is effectively zero. It's like two fireflies flashing just once in the middle of a dark forest. But one flashes on Tuesday and the other flashes on Friday. They never see each other. Someone may have lived on a planet near Proxima Centauri 1 billion years ago. They're already gone. Someone might appear there in 1 billion years. We will already be gone. The tragedy of the universe isn't that it's empty. It's that the guests arrive at completely different times. So when you combine these 5 verdicts, the distance that paralyzes the mind, the speed limit that paralyzes physics, the energy costs that paralyze the budget, the biology that paralyzes the body, and the time that paralyzes connection, the conclusion is harsh. The aliens are not on their way. And that brings us to the elephant in the room. And what about the UFOs and the Navy videos? Look, I love a good mystery, but let's apply the physics we've just learned. We see videos of aircraft accelerating from 0 to Mach 20 in a second. Do you know what happens to matter when that happens? G-force. Accelerating like that would generate thousands of Gs. At that magnitude, the electronic circuits would be destroyed. The metal would become liquid. Biological pilots would turn into a pink mist instantly. And yet these aircraft don't interact with the air. No sonic boom, no ionization trail. An object moving at that speed, in the atmosphere, would tear through air molecules, creating a massive plasma trail that would light up the sky like a second sun. You don't see any of that in the videos. You see a blurry gray smudge. What's more likely? That an alien civilization mastered infinite energy, broke the laws of inertia, canceled out sonic booms, traveled 10,000 light years, and then decided to play hide-and-seek with the U.S. Navy fighter jet. All of that while being captured by a low-resolution infrared camera. Or is it more likely to be a camera artifact? Rotating gimbal reflection? Drone? A bird seen due to the parallax effect? I know it's disappointing. I know we want to believe. But extraordinary claims require extraordinary evidence. And blurry videos are not evidence. They're just blurry videos. If aliens were here, with the power required to make the trip, you wouldn't need grainy video to prove it. The very act of their arrival would be physically undeniable. I promised from the start this wouldn't end sadly, and I'll keep that promise. Because when you discard the fantasy of aliens coming to save us or destroy us, you're confronted with something much deeper. We are forced to face the universe as it truly is, a place of rules, a place of structure. Think about it. If the speed of light wasn't a limit, causality would break down. Effects could happen before causes. The universe would be absolute chaos where history couldn't exist. The same laws that keep us here are the ones that allow stars to burn steadily, atoms to stay together, and life to evolve. The silence of the universe forces us to mature. It forces us to recognize that no one will come to help us deal with climate problems, wars, or the economy. We are the only ones here. This fragile blue marble is the only lifeboat we have. And there is a beauty in this isolation. It makes us precious. If the universe were full of spaceships like in Star Trek, roaming around, Earth would just be a gas station. But in a universe of silence, Earth is a miracle. Life is a statistical impossibility that happened anyway. We are the universe awakening and contemplating itself. And we're not abandoning the search for life beyond Earth. We're just getting smarter about it. We're looking for techno signatures. We're tracking the residual heat from Dyson spheres. We're monitoring laser pulses. We're listening to the stars, not with the desperation of a child lost in a mall, but with the patience of a scientist. We may never shake hands with an alien. We may never share a drink in an intergalactic cantina, but we share the same physics. We share the same elements. The carbon in your right hand and the carbon in the alien's left tentacle were forged in the same kind of dying stars. We are connected, not by spaceships, but by the fundamental laws of nature. So, the next time you look up at the night sky and feel that oppressive silence, don't feel lonely. Feel proud. We are here. We are understanding all of this. We are the seemingly impossible result of 13.8 billion years of cosmic lottery. And for now, that's enough. We need to accept the verdicts, the distance, the time, the energy. But we don't need to accept ignorance. Keep looking up. Keep asking the tough questions. And remember, the universe doesn't owe us an answer, which makes finding it even more valuable. If you've made it this far, you're part of the 1% who truly care about the deeper truth. If you want to join me on the next journey, where we'll break down reality to understand how it works, make sure you're subscribed. Let's keep exploring the silence together. See you next time.